Good afternoon. I thought I'd give you a couple examples specifically from problems similar to what you might find in the book. I chose three separate problems, number 28, and then I'll grab number 57, and then I'll follow that up with number 60, I believe. First kind really carries over from the day before, and if you can handle this kind, you can really handle any of them in this section. This one specifically deals with finding when you know values of theta, finding like cosecant of 30, etc. I'm just going to do two parts of this and how I'd use the information in class to address this. Now, since I'm giving sine of 30 as a half and tangent of 30 is square root of 3 over 3, really, honestly, you only need one of those two in this problem because they told you it was an angle between 0 and 90. You didn't have to worry about changing quadrants or anything like that. Now, I could address this actually a couple different ways. I'm going to go from a triangle perspective. So I'm going to draw a quick triangle, and I'm going to show you I can actually find this from information I already know, but I'm going to kind of recreate it. Sine of 30 is opposite over hypotenuse, so it's 1/2. I can use Pythagorean theorem to find that this side is square root of 3. So at this point I can answer any of the questions. I know this is a 60-degree angle, so really I can find cosecant of 30 and cotangent of 60 without knowing tangent of 30 is square root of 3 over 3. So with that in mind, cosecant's a reciprocal of sine, so it's hypotenuse over opposite. So for the first one, hypotenuse over opposite would be 2 over 1 or 2. Or I could just say, well, cosecant is a reciprocal of sine, so I could flip that over and get its reciprocal. So, a couple options. We can think of identities, or we can think of opposite over hypotenuse. Similarly, cotangent of 60, unfortunately not cotangent of 30, or we could just flip this one over, okay? But we can say, well, cotangent of 60 is a reciprocal of tangent of 60. So cotangent is, if we go to 60-degree angle, we know cotangent of 60 would be adjacent, which is 1, over opposite, which is square root of 3. So 1 over radical 3. Stay in the habit of rationalizing. I can take the square root of 3 over square root of 3, multiply by that to find that it's square root of 3 over square root of 9, which is 3. That doesn't reduce, so my best answer is square root of 3 over 3. I will accept either one. I'll tell you, if you're going to calculus, either one of them is okay. Okay. Our next problem, we have cosecant of theta equals 2 radical 3 over 3, and we're trying to figure out what the value of theta is. Now it says degrees in radians. We haven't talked radians yet, so ignore that part. Hopefully you're watching this video to know that. So we're trying to figure out what theta gives us a cosecant value of 2 radical 3 over 3. So I'm going to do this. I know cosecant of theta is 1 over sine of theta, which means reciprocal of. So that means that implies that the sine of theta is the reciprocal of this, so it's 3 over 2 radical 3. I'm going to rationalize, since I can't reduce it. I'd have 3 radical 3 over 2 times 3, or 6. That's radical 3 over 2 if I reduce. So sine is radical 3 over 2. Well, I know on a 30, 60, 90, sine is opposite over hypotenuse. In order to do opposite over hypotenuse and get square root of 3 over 2, I'd have to be going from the 60 to get opposite over hypotenuse. So that means theta is a 60-degree angle. Without a calculator, I can attack that. We do want to be in that habit. Using the same principles, I know sine of theta is square root of 2 over 2. We're talking about finding the value of theta. Well, square root of 2 looks like it's going to show up in a 45, 45, 90. Sine, well, it better be sine of 45, so let's just check it. Sine of 45 would be 1 over radical 2. Well, 1 over radical 2 is, when you rationalize, square root of 2 over 2. So that means theta is 45 degrees, and I am on to the next question. And finally, we have a problem like number 60. Now, there are various ways to do this. I want to find exact values. So they want us to solve for the missing piece, so we're solving for y. Okay, I know y can be found by looking at the 60. I'm going to go with the 60 since it was given, but technically I know that's 30 also. Okay, I can say, well, that's opposite over hypotenuse, so that's sine of 60 equals y over 18. So I'm going to have y equals 18 sine of 60. Now, I don't want to grab the calculator from this point on. Sine of 60 has an exact value. That calculator is not going to give me an exact value. So I'm going to look right up here, and I'm going to say sine of 60, there's my 60, is opposite over hypotenuse. So sine of 60 is square root of 3 over 2. I'm going to multiply that by 18, and I'm going to think of that as 18 over 1. And I can either reduce that 2 into the 18 9 times, or I can think of that as 18 radical 3 over 2, which is then going to reduce to be 9 radical 3. There are definitely other ways to look at this. This is not necessarily the best. It's one that's consistent with what we've been doing the last couple days. We will see you in class soon.